What makes a study, any study, reliable? So when we talk about the scientific method, we have what we call the hierarchy of evidence. At the bottom, you have things that are generally based on small sample sizes or opinions. From there, you're going into animal trials and in vitro data. So these are your Petri dish studies or your animal data that are not automatically representative of what's happening in people. Say you want to study a disease process in humans and you use an animal model that disease doesn't occur in. That's not going to be an accurate or representative research model because it's not going to give you data that you can then generalize to people. Once you get above that, you're moving into human studies. Randomized controlled trials, they're usually also blinded. Those are considered our gold standard. So with vaccine studies, this is very common. There is a group of people that receive the placebo, which is usually salt water, and there are people that received the vaccine. None of them know what they received. You might report different symptoms than if you knew you were getting the placebo. At the very top, you have what we call meta-analyses and systematic reviews. These are analyses where we take multiple studies and we pool them and analyze them together. There are really high quality journals like JAMA, which is the Journal of the American Medical Association, or PNAS, which is the Proceedings of the National Academy of Sciences. But as a rule of thumb, if you're trying to find information on a given topic, you want to look for, at the minimum, that it is indeed peer-reviewed and that it is aligning with other topics or other papers that are in that field. It is very, very unlikely that one study is going to displace the thousands of other studies within a given field on a topic. We call that cherry picking.